are made up of matter, and so are other forms of life. And on the building blocks of matter are atoms. Now, what make up atoms are primarily subatomic particles, sometimes that are charged.
The real deal is, however, what holds this energy together in the atomic nucleus and is not being swept away from the intricacies of life and its randomness. Well, it all comes down to the attractions and the potential energies which exist within the atom. In 2013, a team of scientists identified a strange item from the remnants of a supernova through the Earth's atmosphere using a gamma ray detector, a particle referred to as the meson. Lucky for us, this is the first time we've encountered the meson. From Hideki Yukawa's initial predictions of the meson back in the 1940s, this particle is made up of two rudimentary particles of matter referred to as quarks. Individual to other hadrons, it has an antiquark and a normal quark pairing that makes it itself a meson. However, how could the meson be applicable in the atomic nucleus? The atomic nucleus contains two types of nucleons. Inside, there are quarks that are held stable by gluons. Now, the quark's nature of using gluons for attraction means they desire interaction with other quarks inside of other hadrons, so they'll form the meson. Think of it as if it were a tug of war or an infinite chess game that always leads to a stalemate. Both sides need to get closer to the goal, but there's an equal force that is given, the meson, keeping up the tension, thus keeping up the game as they start to close in on each other. As time elapses, the meson's constant sharing forges this tension, this attraction that closes the gap between the neutron and the proton. And thus, the strong nuclear force is produced, where it is a physical force that is governed by the interactions of the quarks within the nucleons, which then produce mesons that are then exchanged by the nucleons, which then promotes the meson theory. The attraction, stability, and order that the meson structures in the atomic nucleus is universal to any type of atom, any element, and can determine the behaviors of each element to the atomic level. By keeping the nucleus together, it can produce these elements and create the attractions and the bonds that are existent in life today. So let's figure out the quarks of our universe one particle at a time.